What if I told you that every click, every game, every app, and every video you watch is controlled by a tiny chip smaller than your hand? That tiny chip is the CPU, the brain of your computer. Welcome back to the channel. If you enjoy simple and clear technology videos, make sure to like, subscribe, and share this video. Today, we're going to explore how a CPU actually works. The CPU stands for Central Processing Unit. It is the main component responsible for processing instructions and telling the computer what to do. Whenever you open a game, type on a keyboard, watch a video, or even move your mouse, the CPU is constantly working in the background. But how does it really work? Everything starts with instructions. Programs are basically huge lists of instructions written in code. The CPU reads these instructions one by one at extremely high speeds. A modern CPU can process billions of instructions every second. The CPU works in a cycle called fetch, decode, execute. First is fetch. The CPU fetches an instruction from the computer's memory, usually RAM. Then comes decode. The CPU translates the instruction into signals it can understand. Finally comes execute. The CPU performs the action. This could be doing math, moving data, opening files, or rendering something on your screen. Then the cycle repeats again and again billions of times every second. Inside the CPU, there are several important parts. One of the most important parts is the ALU, which stands for Arithmetic Logic Unit. This part handles calculations and logical operations. For example, when a game calculates damage or your calculator app solves math problems, the ALU is working. Another important part is the control unit. This acts like a manager. It controls the flow of instructions and tells different parts of the computer what to do. Then there are registers. These are extremely tiny and ultra-fast storage spaces inside the CPU. They temporarily hold data that the CPU needs immediately. Modern CPUs also contain something called cache. Cache is a very fast type of memory located close to the CPU cores. It stores frequently used data so the CPU doesn't need to constantly ask the slower RAM for information. This helps make the computer much faster. Speaking of cores, modern CPUs usually have multiple cores. A core is basically like an extra brain inside the CPU. Older CPUs had only one core, meaning they could handle one main task at a time. Today, many CPUs have 4, 8, 12, or even more cores. This allows computers to multitask much more efficiently. For example, one core can run a game while another handles background apps and another processes voice chat. You may have also heard the term threads. Threads allow a CPU core to handle multiple instruction streams at the same time. This helps improve multitasking and overall performance in many applications. You may have also heard of clock speed. Clock speed is measured in gigahertz, or GHz. This determines how many cycles the CPU can perform every second. For example, a 4 GHz CPU can perform around 4 billion cycles per second. But clock speed alone does not determine performance. Architecture, cache size, power efficiency, and core count also matter a lot. Modern CPUs are incredibly advanced. They can predict instructions before they happen, process multiple tasks at once, and optimize performance automatically. Some CPUs even include built-in AI features to improve gaming, video editing, and productivity tasks. Today, some high-end CPUs contain billions of tiny transistors packed into a single chip. These transistors act like microscopic switches that turn on and off incredibly fast to process information. The smaller the transistors become, the more powerful and efficient CPUs can get. Companies like Intel, AMD, and Apple constantly compete to create faster and more efficient processors. And despite all this power, CPUs continue getting smaller and more energy efficient over time. The crazy part is that all of this happens in milliseconds. Every movement, every click, and every action on your computer depends on the CPU working non-stop in the background. Without the CPU, computers, phones, consoles, and even smart devices simply would not function. Technology keeps evolving rapidly, and CPUs are becoming more powerful every year. From gaming PCs to smartphones and massive servers powering the internet, CPUs are at the center of the digital world. Scientists and engineers are already working on future technologies that could make CPUs even more powerful than they are today. As technology continues advancing, CPUs will remain one of the most important inventions in the digital world. Thanks for watching. If you enjoyed this video and learned something new, make sure to like, subscribe, and share. And comment below what technology topic you want to see next.